In example 3 of our solving logarithmic equations video, part 2, we have the log of x plus 2 plus the log of x plus 5 is equal to 1. No base is written, so we're assuming that this is a common base. We know that it's a common base of 10. If it helps you, you could write it down. And be careful when you're writing the base to write it as a smaller number and below the word log, the abbreviation log, as a subscript. And another part of this is to realize that the property of logarithms, the product rule, was used here because I have a sum of individual logs. Therefore, I know that I can rewrite this working backwards as the log of x plus 2 times the log times x plus 5. The log of x plus 2 times x plus 5. We're going to condense that, and that's equal to 1. Now we're going to rewrite this in exponential form, where we have, again, we could, if it helps you to write the base as 10, the common base. Log base, here's the anti-logarithm or the answer, equals the exponent. So we're taking 10 to the first power, and it's equal to x plus 2 times x plus 5. And again, it's important to notice that the product rule of logarithms was used. Ten to the first power is equal to x plus 2 times x plus 5. 10 to the first power is 10. Over here we're going to have to FOIL, double distribute, a binomial times a binomial. We're expecting our answer to be a trinomial. After distribution, double distribution, x times x, x squared, outer, 5 times x plus 5x, inner is a 2x, and lastly a 10 plus 10. And then we're going to reduce the right side, x squared plus 7x, combined like terms, plus 10. We now have a quadratic equation that we have to solve. And when you have to solve a quadratic equation, you want to have 0 on one side. So we're going to move this 10, we're going to subtract it from both sides. So now we do have 0 is equal to x squared plus 7x. The 10 and the negative 10 cancel out. We can use GCF factoring and divide out an x out of both of these terms, leaving us with an x plus 7. And again, the way that I got x plus 7, x is your GCF out of those two terms. And then you're going to take x squared divided by the GCF x and get x. Take the 7x divided by the GCF and get 7x divided by 7 divided by x is 7. So now we have two factors. We're going to set them equal to 0 to solve. X could be equal to 0, or this factor x plus 7 could be equal to 0. X equals 0 is straightforward, that's one of the roots. And then you also have x minus 7. Subtract 7 from both sides, so then you're going to have x is equal to negative 7. It is important that we check that both of these answers are valid by substituting them into the original. So we're going to first check to see if x equals 0 is valid. If we take x as 0, this would be the log of 2 plus the log of 5. So on our calculator, we're going to see if the log of 2 plus the log of 5, and it comes out as equal to 1, which is working. So that is definitely a solution. The other solution that we got was negative 7. Let's check that one out. If we take negative 7 and plug it in, we would get the log of negative 7 plus 2. So that would be the log of negative 5. And again, we can use our calculator because it's a common log. The log of negative 5 plus the log of, again, x is negative 7, so this would be the log of negative 2. We're adding on the log of negative 2. use parentheses, and you'll notice that you get an error. So that means that we're going to keep this solution, however, we're going to reject this solution over here, since it didn't work out and it made an error on the calculator.